Hello, dear friends. I hope you have understood the previous lesson on VOR. And as you know, I am doing this series on navigation numericals, right? So I'm going little bit into the theory, although for theory, I will bring out a separate series. So those who remain with me will, in the time to come, have the benefit of also going through the theory. I started with numericals, which a lot of people find difficult and make mistakes and lose marks. Theory is easy. You have to remember it. Here you have to understand and do the numerical. Okay. And today, me, SK Booty of Booty Aviation Training will cover for you ILS instrument landing system, and I repeat, I will be concentrating on numericals. How to handle and what are the types of ILS numericals that one may expect. Here we are. As you know, this instrument helps you land in adverse weather when you visually possibly cannot see the runway, maybe the visibility is bad or there are low clouds, then you can carry out an instrument landing system. It has an ILS meter with the two needles. One is vertical needle called localizer needle, and one is a horizontal needle called glide slope or glide path needle. If these two needles make a cross at the center here, like this, that means you are descending in the direction of the runway center line, as also you are on a proper glide path angle, also called approach slope angle. And this particular line on which you'll make a descent is called approach slope. And standard glide path angle between approach slope and the horizontal is 3 degrees. There are places where there is a obstruction somewhere short of the runway, then this angle may be increased slightly. So if the aircraft remains on this center line, both your needles will remain centered if you remain on this approach slope, and you will make a good landing. You will be placed for a good landing. The ILS will bring you over the threshold at 50 feet above the threshold. For numericals, we'll take a value of 50 feet. At some places, it may be slightly higher. Right? There are two transmitters. One is called a localizer transmitter, and that is called upwind end of the runway, 300 meters from here, which transmits on a VHF frequency, which you will select on your selector box, two directional signals called lobes. While tracking inbound, the blue lobe on your right hand side is 150 hertz, and a yellow sector of 90 hertz is on your left. If you are on this line, it is called an equal signal line. You will receive equal signal from both these lobes, 150 and 90 hertz, and the needle will remain in the center. Here it has gone off center. There are many types of radar equipment indicators. Here you see these two. The vertical needle is vertical and moving left and right. Horizontal needle is horizontal and moving up and down. There are some in which the needle swings like a pendulum. Similarly, the horizontal needle, called the glide slope needle, also swings up and down. And in some cases like these two, the needle moves left and right and up and down, and they serve the same purpose. Fine. From this number of dots, you can find out where are you with respect to your glide path or center line of the runway. The vertical needle, now called the localizer needle, will remain in the center in case you are on the center line. Here it has gone to the left. It is telling you to fly left. That means you are this side of the center line. If I know this closing angle, then I can find out how many feet I'm away from this center line, called distance of drag. And those are the type of numericals. How will I know what is my closing angle? Right? The full deflection of the needle will occur at 2.5 degrees either side. So on a 5-dot indicator, each dot will represent 0.5 degrees of closing angle. In this case, the needle has gone 1 dot to the left, means fly left, 0.5 degrees is closing angle. Here it has gone on to 2 dots, means 1 degree of closing angle. This is a separate aircraft, and this is a separate aircraft, right? The glide path full deflection occurs at 0.7 degrees above or below the glide path. And remember 0.7, not 7 degrees. The total glide path itself is 3 degrees. So therefore, this is the blue sector, 150 hertz below, 90 hertz above, and the carrier frequency is UHF. And higher the frequency, you remember, smaller is the wavelength, greater is the accuracy, right? Now, if you remain on the glide path, this needle will remain here. Here, I've told you the numericals are find out the closing angle from this vertical needle where it has gone. If needle goes to left, you are to the right. Needle goes to right, then you are to the left. And with the closing angle, they would possibly ask you, what is your horizontal distance, which will be rather distance of drag, which will be distance away from the center line. If this is given to you, then he can ask you distance to go, etc. Application of 1 in 60 rule. And we had done quite a few questions on that. As far as the horizontal needle is concerned, when aircraft goes below the glide path here, the needle will go up, like in this case. If the aircraft goes above the glide path, needle will go down, in this case, telling you to fly down, and fly up are the indications. While it is desirable that you remain exactly on the glide path, but if your needle has gone up, now watch, don't let it go too much to the higher side, and maximum safe deflection permitted is half of the full deflection, and full deflection is 0.7. So you should not go more than 0.35 degrees below the glide path. On a 5-dot indicator, it should be the needle should not go more than 2.5 dots above, up, fly up indication, right? Then what are the type of numericals? Now he can ask you, one simple question can be that you are so many nautical miles from the runway threshold, or he says you are on the outer marker, which is 4 nautical miles from threshold, or he may give me readings from the precision DME. Precision DME is a distance measuring equipment. Transmitter may be located anywhere but it will give you the distance from the beginning of the runway threshold. So with the PDME, you are getting distance to go. With the localizer needle, you are left or right of the runway. Horizontal needle tells you whether above or below the glide path. And this three-dimensional picture is being given to you when you can see nothing outside and you are in clouds. So here it is, a wonderful equipment called instrument landing system. Right. Now, let's say what type of numericals can be asked. Here, aircraft goes left and right and they'll ask you how many feet. Here, aircraft goes up and down. They will ask you that how many feet you are from the ground. And if you are crossing an obstruction from here, how many feet you are above that obstruction. So I have to solve first this triangle, red, and let's take a standard approach slope angle of 3 degrees. And this indicator is showing you one dot to the left. That means you are below the glide path now. Sorry, not to the left. One dot, fly up indication. And each dot on a 5-dot indicator will be 0.14 degrees. That means you are 0.14 degrees below the glide path. And instead of 3 degrees from the horizontal, you are 2.86 degrees. 3 minus 0.4. Now with this 2.86 degrees as the closing angle, take this as distance off track and this as the horizontal distance, and don't forget to convert it into feet so that you get this answer in feet. Vertical distance is known to you. You can find out horizontal distance. Horizontal distance is given to you. You are so many nautical miles from the threshold, converted into feet. Now we'll ask you what is your aircraft height. This height which you'll get originally will be from this ILS reference datum. So if he says above the ground, how many feet? Add 50 feet. And that will be your distance above ground. And if he says there is a hill here of so many feet, how many feet you are above the hill? Then find out your distance above the ground. Hill above the ground is given to you. Rest will be your vertical clearance from the hill. So these are the type of numericals. In this case, needle has gone 2 dots below. 2 dots means 0.28 degrees. That means you have gone above the glide path and your glide path now is 3.28 degrees. Actual glide path. Okay, if he says what should be my rate of descent now? Remember glide path angle into ground speed by 60 into 100 feet per minute. So tell him that should be my rate of descent now. If you are above the glide path, you'll have to increase rate of descent. If you are below the glide path, you will have to reduce. And if you have gone more than 0.35 degrees below, immediately make a maximum gradient climb, maximum angle of climb, intercept and maintain the glide path. So these are the 1 in 60 numericals. Remember, this point is 50 feet above the ground. So when you calculate this vertical distance with 1 in 60, if he says, tell me how many feet above the ground, add it. How many feet above the mean sea level, then add the elevation of this place also. So that is your guidance for ILS numericals. So I have given you sufficient guidance. Now I'd like you to try a few numericals, which I will give you in the next lesson, along with the numericals for VOR and ILS combined. Point to remember is VOR full deflection is at 10 degrees, and in ILS localizer it is 2.5 degrees, and glide path 0.7 degrees. Divided by the number of dots, give you the each dot value. Okay. So now I will say bye-bye to you for the time being for this lesson, and looking forward to see you in next lesson, in which I will give you a lot of numericals for practice. And don't let my effort go waste. Please do those numericals. Check your answers, do them again. Check your answers only after doing the numericals. And if you need any help, come back to me in comments. Looking forward to your comments. Looking forward to your like the channel, like the video, subscribe the channel, and also press the bell icon for notification, as also forward the channel link to your friends. Good luck. Happy landings. All the best. See you next time.